I've been asked a question about membrane cosmology and my opinion of it. And so I'm going to talk to you about it, and it's interesting. So the original idea that people had was that everything was made up of strings. Later, there was a revolution when people realized you could extend the strings from being these one-dimensional, tiny, very tiny objects that into membranes. That is, you can add extra dimensions to them. Instead of just being one-dimensional, they can be two-dimensional or more. And the reason is, when we look at physics, there's lots of symmetries in physics, and some of them have degrees of freedom, and you can assign them to be equivalent to dimensions. And string theory wanted the universe to be 10 dimensions, of which 4 are large, 1 time and 3 space, whereas membrane theory wants there to be 11 dimensions. And it actually turns out that actually makes things more symmetric and more unified in a certain way. And then you can condense that to 10 dimensions to get string theory out of it. So it's a superset of string theory. And that is very powerful mathematically. It has limited success in describing the real world, although it's one of the ways that people try and understand black holes and the information content of black holes. But if it's a true theory, and there are a lot of physicists who work in string theory and membrane cosmology, membrane theory and membrane cosmology, and believe it's got to be true because it's so pretty or whatever, it's so symmetric. And they work very hard to try and make it work. And some of my colleagues and I are actually trying to look for one of the products from this membrane cosmology and the things that were necessary, because you have to sort of break the symmetries in order to get the universe we see today. And it was hoped that there were only 1 degree of freedom, but now with membrane cosmology, there's extremely large number of possibilities, and you have to come up with an idea of why the universe is the way it is and how it picks the thing it does by breaking symmetries and collapsing down into the universe that we might exist. So what it would say is, we are very conscious of the 4-dimensional hypersurface, the 1 time, large time dimension, and the 3 large space dimensions. We don't notice the really tiny, very, very tiny other dimensions that are attached to every part of our space-time. But it gives us guidance and theoretical ideas and stimulation to try and think about other things to be done. And there are a large number of bright people working on trying to turn those things into implications for cosmology and to understand why the universe is the way we see it today. And so I think a lot of effort is going to that. Whether it's a correct one or not, it's too early to tell. There is very little experimental proof that this is the right track. It's just the fact that the mathematics all fits together so nicely that keeps people convinced that it's probably the right thing. And so, will it become a mainstream theory? Well, it is a kind of a mainstream theory, but without so many predictions. Will it stay a mainstream theory? That's hard to know. It depends on what we observe. If we started to see particles that are left over from early Bose-Einstein condensations of the higher dimensions collapsing down to smaller, and that's the dark matter, well, that'll make people all excited and think that's probably right. If we don't see that, well, they'll keep working and thinking they've got it. We'll see what happens. It's one of those things where the question is it a beautiful theory that's going to be slain by the ugly fact? Or it's just a beautiful theory, like the steady-state model of the universe, but it doesn't describe the actual universe the more crude Big Bang model does. So we have to see. So it's a lot of people are betting on it and put a lot of their time and life effort onto it. I think eventually nature will decide whether we're right or not. We'll look and we'll see whether it agrees.